Hi, this deck was compiled in order to facilitate getting through standalone questions about solubility equilibria, and it's the second volume in the series for solubility equilibria. All right, and there should be a third one coming on the way. Name each entity represented in CASH-N-GIA, the acronym for soluble compounds. So what does CASH-N-GIA stand for? And remember, these are the soluble compounds. Okay, that would be chlorates, acetates, sulfates, halides, except for fluorine. Group 1 metals with lithium, sodium, potassium, and ammonium. HAP key. Identify the metal cations in this mnemonic for insoluble halide compounds. So what does the HAP and HAPPY stand for? And remember, these are insoluble halide compounds. All right, so in halides, that's fluorine, chlorine, bromine, iodine. When they pair with mercury, Hg2, 2+, that's a diatomic, okay, molecule. Silver, Ag+, and lead, Pb2+. It's also diatomic in this form. So definitely memorize this, all right? So just take it all in and be sure to memorize. CBS. Identify the alkaline cations in this mnemonic for insoluble sulfate compounds. So when I say alkaline, I mean group 2A elements. So that would be calcium in the third row, actually in the fourth row of the periodic table, barium in the sixth row, and strontium in the fifth row. All right. So be sure to memorize these. CBS. Hydroxides. Hydroxides are insoluble except when bonded to blank, aluminum, and ammonium. So what other thing or entity is hydroxide soluble with, okay? When I say hydroxide, I mean the OH negative polyatomic anion. So when bonded to aluminum and ammonium, it's soluble. And bonded to what else will it be soluble in solution? Again, that would be group 1 metals. And when I say group 1 metals, I mean sodium, lithium, potassium, and then the other ones aren't usually mentioned, like rubidium, cesium, francium. Those are group 1s also, but they're less commonly used as examples, but who knows, they could show up. So just group 1 metals is a generalization, and you should definitely memorize this solubility rule. What is the molecular formula for cupric hydroxide? So what's the molecular formula for cupric hydroxide? The molecular formula for cupric hydroxide is Cu, of course, the copper portion, OH2, and it's in solid phase. Okay, so definitely memorize this. Write the molecular formula for copper phosphate. So what's the molecular formula for copper phosphate? It's Cu3 PO4 2 negative, okay? And that's in solid phase. And I think in a previous deck, I told you that the charge on the phosphate anion was -3, okay? Or, it would be written 3 negative because oxidation states have the signs in front of the numerical coefficient. And cupric means the charge, copper can expand its octet because, well, it can have different oxidation states, I should say. Scratch the octet thing because it's has d orbital, so it can assume different energy states. That's why it can have more than one oxidation state. So this form is 2 negative. That jig-jag is supposed to be like a 2. Well, the charge is 2 negative on cupric. So definitely memorize this one also in its solid phase, as you can see written down. All right, so memorize. When the ion product is greater than the solubility product constant, the solution is considered saturated or unsaturated. What's the best fit? So here we're comparing the ion product being greater than the solubility product. That means like there's a lot of ions in solution as opposed to solid stuff, which is described by the solubility product. All right, you might have guessed it. It's unsaturated. So if I have a lot of ions floating around in solution, it's not saturated, it's unsaturated. Things are not going to precipitate out. What is the molecular formula for thiosulfate? Okay, thiosulfate. And remember the root word or the prefix thio. Theo, I'm not sure how it's really pronounced, but you see how it's written. It's prefix first sulfur. So here you have double sulfur, theo and sulfate. We know that's like SO something. So what's the molecular formula? All right, so it's S2O3, and the overall polyatomic ion has a charge of 2 negative. And as you can see, it's in aqueous phase. It's a solid dissolved in water. So definitely memorize this one. The charge and the formula, everything about it. Well, not everything about it, because that's just overkill, but you know what I'm trying to say. All right, this one might seem long, but it's just a defining card, so that's why there's so much detail. When gases dissolve in a liquid, it is an endothermic or exothermic process. Due to the latent heat released when the gas is brought from the gaseous to liquid or aqueous phase. So is this endothermic or exothermic? Oh yeah, as you might have guessed, it's exothermic. And the big hint word was the latent heat release. All right, the solubility of most solids increases as temperature increases because the dissolution of solids is an endothermic or exothermic process. Which one is the best fit? All right, so don't get tripped up. It's going to be endothermic because as the temperature increases, energy goes into bond breaking, okay? So that's an endothermic process. All right, so what is the equation for the formation constant? That's K sub F in terms of KEQ and KSP, where KEQ is the equilibrium constant and KSP is the solubility product constant. Okay, so sorry for this. I'm not sure why this is happening. Okay, so K sub F equals KEQ divided by KSP. So take it all in and definitely memorize this formula.